Hello, good people. In front of us, we have May 2023, paper 2, Timezone 1, question number 2. You can pause the video and then try it yourself before we discuss it together. Okay, for this question, we have a function given, which is f(x) is equals to 3x minus 1 plus 4x to the power of negative 2. It's clearly stated here. We have the window as well, so later when you input it to your calculator, you already have the window. Okay, the function is defined for all values except of x equals to a. We have to write down the value of a. Now this is what we call as asymptote, which is a value that you cannot have, like you and your crush. You are getting closer and closer and closer, but you never touch it. So sad. So in this case, this is the red line is the asymptote. The equation for this line is x equals to 0. The y-axis x equals to 0. So it means the value of a is equals to a. A is equals to 0. So x equals to 0, a equals to 0. That's asymptote. B. Use your graphic display calculator to find the coordinate of local minimum. Now, local minimum is this point. This is not the minimum because we know that the graph is still going down here, as you can see. But the local minimum is this. Locally, this is the minimum. To do that, we have to input it to our calculator. Wait, what was the function? Okay. Go. I already set my window following the table. Sorry, following the picture. Let's input it to our calculator. We have 3x minus 1 plus 4x to the power of negative 2. And then graph. There you go. This is our local minimum. Let's find the minimum. Second trace the minimum. Enter. Left bound. It's oops. Cannot it. Okay, that's as long as it is on the left of the minimum. Enter. Right bound. As long as it is on the right. Enter. Guess. No guess. And then the minimum is 1.3862. 5.24025. So B. What was the question B? Use a okay. Local minimum is, this is only 2 marks. So we have 1.38672, comma. Oh my God, we don't have enough space. Sorry guys, I'll put it here. So B is 1.3862, comma 3867.2, comma 5.24025. 5.24025, or approximately you can write it as 1.39, comma 5.24. Okay, that's question B. This is 2 marks, 1 point for each of this. So this one 1.39, 1 mark, 5.24, 1 mark. Okay. C. Identify the one possible value for W. The equation, okay, X has 3 solutions. Now 3 solutions. It's meaning like this. Let's say I have this one. If I have this value horizontal, we have only 1 solution. Okay, let's say I have this y equals to 2. We also have 1 solution. Now it start having 3 solution when it is above the minimum point. This one, this is 3 solution. 1, 2, 3. Okay, so where is the minimum point? The minimum point is here, 1.39, 5.24, meaning the possible value for W, it should be more than the value of this 5.24. So W, it should be more than 5.24. Okay, once again, if it is 5.24, we only have, let's say it's 5.24, it's here, we only have two solution. But if it is more than that, we have three solutions. That's question C. Question D, what's question D? We have the line y equals to mx is y equals to mx minus 1 over 4 is tangent to fx when x equals to negative 4. Now x equals to negative 4, it means this area. We can take a look at the graph when x is equals to negative 4. This graph, can you see it? It's going up. Okay, it's from the left to right. Yeah, it's going up. Let's see how many points. Okay, it's only 2 marks. There are 2 ways that I can come up in my brain. The first way, you can use the first derivative, find the tangent line using calculus. Second way, you can just take a look at the properties of the graph. The graph is going up. If the graph is going up, meaning the gradient is also positive, the tangent line. So for question D, it's only to mark as question D, but you have to explain why it is positive, yeah. As the graph go up when x equals to negative 4, then the gradient m is positive. Okay, you have to give your reason. Without your reason, that will be wrong. You can just say, okay, it's positive. No, you have to give the reason. Second function given by gx equals with k p to the power of x minus 9, where p is more than 0. The graph intersect y-axis at point A 0, negative 5 and pass through point B 3, 4.5. Find the value of k. I'll do it down here because this one a little bit algebraic manipulation. So we know that the function gx, sorry, this is question E, gx is equals with k p to the power of x minus 9. We will use this first point A. When the gx is negative 5, the x is 0. Let's input that. So when the gx is negative 5, k times p, the x is 0 minus 9. So everything to the power of 0 is 1. So negative 5 equals with k times 1, we don't have to write, minus 9. So k will be a negative 5 plus 9. So k is equals with 4. That's our k. And then we have to question p. This is I. P, we will use what we have. So gx is equals with, the k is 4, p to the power of x minus 9. Now we will use the second point given to us, which is in this case the x is 3, the gx is 4.5. So let's input it. So 4.5 is equals with 4 times p to the power of 3 minus 9. So we will have 4.5 plus 9 gone, and then it's times 4 here, meaning divided by 4 equals with p to the power of 3. Now to get rid of p to the power of 3, we will do the third root of that. So gone. So we will have p equals with, let's input it to our calculator. Okay, oops, we have, okay, 4.5 plus 9 is 13.5. You don't have to type that. Divided. You don't have to input it in the calculator if you can share. So we have P is equals with 3.375. Oh, but we need to the third root of that. I forgot we have to make the third root of that. So math the third root of the answer. Enter. We have 1.5. So P is 1.5. There you go. Okay. Write down the equation of the horizontal asymptote of y equals to gx. So asymptote, like your crush that you can never have. Sorry. F. We know gx is equals with the k is 4 times p. P is times 1.5 to the power of x minus 9. We have to find the asymptote of this. You have two ways. The first way, you can just graph it to your calculator and then see the pattern. Okay, so we have, what was the question? 4 times 1.5 to the power of x, the power of x minus 9. Okay, let's see whether we can see a horizontal asymptote. Okay, horizontal asymptote is this way, the horizontal one. Okay, I think we need the y a little bit. I suspicious that the asymptote is here, down here. Let's change the window of the y min become, let's say, negative 15, and then x min, let's say, negative 20. Just want to see the pattern. Okay, here's the asymptote. Can you see it? This red graph, it will never go below this certain point over here. Let's find the value of that. Second trace the value of x equals to, let's say, at x is here, x is negative 15. Where do we go? Enter. Okay, I don't want the blue one, I want the red one. Okay, sorry, I want the red one. I don't want this. Okay, enter. I only want the red line. Okay, let's do it again. Second trace the value when the x is negative 15. Enter. Okay, it's negative 8.99, so it's getting closer to negative 9, but it cannot reach negative 9. Once again, it's like your crush that you can never have. So it means the asymptote is y equals to negative 9. Once again, looking at this value, the graph want to go to negative 9, but it cannot. So sad. So it's just trying, but it can never, you know. Okay, that's sad story. Okay, wait, are we doing it correctly? Write down the equation in this of y equals to x. Okay, this is equation y equals to negative 9. So if it is the equation that they ask, you have to write it as equation. You cannot just write asymptote is negative 9. No, you have to write asymptote is y equals to negative 9. Or you can just horizontal asymptote is y equals to negative 9. That's question F. Question G. What's question G? Find one solution of x equals to gx when x is more than 0. Okay, it means we need the blue line again. Okay, graph. Okay, when the x is more than 0, it means positive. We have two intersections, as you can see. This is the first intersection. We don't need this because this is in negative x. We need the x in the positive, which is here. Okay. So let's do the calculation. Second trace intersection. Enter. The first graph. Okay. That's the first curve. You have to bring it to here, yeah, because we have two intersection. Second curve here, but not too close, because once you enter it, enter. Now once you enter it, you will have this, the intersection. So the intersection is x equals to negative, x equals to 4, and then y equals to 11.25. What's the question G? Find the solution fx x equals to 0. Okay, so it will be the same. Okay. Oh, it's wrong. What was how was the graph? Okay, it looked like that. I'm writing this as a way for me to show to the assessor that okay, this is how do I find it. 11.25. 11.25. So fx will be equals to gx when x equals to 4. There you go. You don't have to write the point because it's only asking you what value of x when fx and gx is the same. Okay, just write x equals to 4. H. Okay, we have question H. Okay, consider a third function h. We have third function where hx equals to fx plus gx. The point C, negative 1 comma q, lies on the graph of gx. Okay, so we know that this okay. State whether C is also lies on the graph of hx. Justify your answer. Okay. hx fx. Okay, we have hx equals to fx plus gx. We have point C, which is negative 1 comma q. Now let's break it down. Okay, we know that this point C is in this graph. Okay, so to see whether this point is also on H, we have to check fx. Okay, let's see what fx has. When the x is negative 1. Wait, what was our fx? Okay. Oh, wait. We don't have to input it to... We don't have to calculate it manually. When f is negative 1 equals to it, we have the calculator. The fx is the blue one. Okay, so we don't need the red one. Just go to the blue one, graph, and then second trace the value when the x is negative 1. Okay, when the x is negative 1, the y is 0. It means when the f is negative 1, the answer is 0. Now, it will have consequences on this equation, meaning when the x is negative 1, the value of fx is 0. This one is 0. If it is 0, it will not change anything. Okay, so we have hx will be equals to gx. Since since point C is on gx, it means point C is also in hx in that particular point, because once again, because the fx is 0. So how do I write it? So since f negative 1 equals to 0, then then hx will equals to gx. So okay, so point C will be on hx. Okay, so what happened when f1 negative 1 is not 0, then it will be different case. Okay, because the value of f negative 1 is 0, it doesn't it makes the hx equals to gx. Okay, so that's it for this question. I hope this can help you. Thank you.